Picking back up with Calculus BC, our review for our Chapter 7 quiz, we're going to look at number 7. As you look at this integral, obviously you have a natural log in it, but it's pretty clear that there is no obvious antiderivative that you can just take to work this out. Very likely then a u substitution is going to be required. The big question is, what should you choose for your u substitution? Let's try natural log of x and see what happens. If you had du here, you'd get 1 over x dx. And if we were solving for dx, we'd get x du. Now, the bounds of integration are going to change. You have an x value of e, and that means that when you plug that in right in here, natural log of e is going to be a 1. Likewise, if you plugged in x equals e squared, the natural log of e squared would be a 2. So your boundary, in fact, does change. Now, dx here is really going to become an x du, and you can see that our x's completely wipe out. Now we just use our fundamental theorem. We'll get u squared all over 2. We're going to evaluate that between 2 and 1. And that would be 2 squared over 2 minus 1 squared over 2. So that's 4 over 2, which is 2, minus 1 half. 2 minus 1 half is 1 1/2, or 3 over 2. Let's take a look at number 8. Again, maybe the thing to try here is to perhaps try another u substitution. You can see that it looks like we've got e to the x inside the secant squared. We also have an e to the x outside. One of the nicest things is that u equals e to the x. You just have du is e to the x dx. And you can solve for dx, and dx is du over e to the x. So we will have secant squared of u, but our dx, of course, becomes du over e to the x. E to the x cancels out. Now the antiderivative of secant squared we should have memorized. That's tangent of u plus a constant. But our u, of course, has to get resubstituted in this regard. When we have an indefinite integral, when we're answering really in an algebraic format, we want to have x's in our answers here. Okay, let's keep going. As we look at number 9, quick review. We have a 6 to the rad x here. And really what you're going to remember, I hope, is if I gave you something like 6 to the u du, you're probably thinking, well, wow, I might have forgotten that a little bit. Remember what the derivative of 6 to the u is. It would be 6 to the u ln of 6. So ultimately, if we can create an ln of 6 inside and then counterbalance it, then we could say the antiderivative of 6u ln of 6 going backwards would just be 6 to the u. Then we'd have this 1 over natural log of 6 right here. Now that's a much simpler problem, but what I'm trying to drive home is this exact type of thinking, that maybe a u substitution could come into play. If we had u equals radical x is one of the most famous derivatives. I hope you've got it memorized. It's going to be 1 over 2 times radical x. And if we were to solve for dx, that would be 2 radical x du. So this integral will become 6 to the u. That'll have my radical x right here. My dx becomes a 2 radical x du. And sure enough, these radical x's are going to go away. At this point, I do want to tell you that it's now what I had talked about at the start of the problem. It's really saying if I remember that this derivative of 6 to the u is going to be 6 to the u ln of x, I essentially want to work backwards. So again, I do this regularly. I actually do this every single time. I'll say I'd like to see an ln of 6 in here, and then I'd counterbalance it by putting an ln of 6 down below. Why do we do that? Well, because now I'd have 2 over the ln of 6, but this antiderivative. What's the antiderivative of 6 to the u ln of 6? It's just like what we have here. It's just 6 to the u. And then, of course, we're going to have plus c. But once again, we can't leave our answer with a u here. Algebraically, we're working this out with respect to x. So a final answer that we'll have is 2 over ln of 6 times 6 to the radical x here plus c. And that's going to be our final answer. We're going to do one more problem here on this video, and then we'll make a new one. But for number 10, I think it could definitely get to be a little intimidating at first glance. What you need to do is square the top and square the bottom. Now, if you square the top, you'll have y squared plus 2y plus 1. Square the bottom, you'll have a y squared. And then separate, do an I heart math, and turn this into 3 distinct fractions. We'd have y squared over y squared. Here's a 2y over y squared. And here's a 1 over y squared. And y squared over y squared, of course, is just a 1. This becomes 2 over y. This thing right here is really y to the negative 2. And you might wonder why I wrote the last one with a negative exponent, and yet in the middle I did not. As we wrap this up, the antiderivative of 1 is just a y. Antiderivative of 2 over y, the 2's out in front, but it's the natural log of the absolute value of y. Now this thing right here, y to the negative 2, if you were to take an antiderivative, you'd have to make it y to the negative 1 over negative 1. You bump your power up, and it would effectively become negative 1 over y. Don't forget you'll need a plus c for a constant, and that is number 10.